So now we're going to start building our node. At this point, it's a good idea to save your scene. I already have my scene set up to be saved. And what we're going to be using is the ground object, or really any object in the scene, and opening its object graph. Now, we're not going to be using this object to control our node we're creating, but we're just going to use this as basically our template and object in order to build our node, and then we can save it out and load it in anywhere. Now there's one thing to keep in mind, and that is sometimes metanodes changes you make to the node, and some of these graph functions will not save unless you manipulate the object to let view know that the object's been changed. In other words, if we were to make a change to this node and add in, let's just say, this noise node, click OK. Now when I go to File Save, it hasn't recognized that I've done anything in the function. So what we can do is just move our ground a little, and now if we save, it will save out this connection. So if you are going to be working on a function and saving it, then it's a good idea to, every once in a while, just click OK, move the object you're working on, save it, and that way it'll save the node with it. What you could also do is once we get into the node stage where we can create the meta node, then you can start saving out the node versions, and that'll also help and guarantee a save rather than having to trust the fact that it recognized the overall change. So the first thing we're going to do is right mouse click and add in an input node, which is going to be an external dependency. Now you can't create a meta node with only one node. We do want to get to the meta node stage as quickly as possible, so we can save this out. So what we need to do is add in another node. I'm just going to add in a constant node, change this to a constant number. We can select these two, and now up at the top, make a meta node. Now that we have the meta node available, we can start saving out versions of it. If we go to Edit, it's going to open up our meta node graph. And with this open and edited, any parameter we want to extract to show up in the main interface of our node, as we're working on it and extracting a parameter, it will show up within the node, and now we can see that as we're working on it. I'm just going to unpublish that. And the first thing we need to deal with and work with is our internal unit. And because the internal unit can vary between scene and scene, we need to make sure this node is flexible enough to be able to move over to different scenes. And this is actually a really simple and easy connection and doesn't require a whole lot of work. What we need to do is create a math node. We're going to set it to multiply. And now we can connect this to our external dependency, which we haven't selected an object, and we're not going to until we start using the node and testing it. But what we have a connection to right now is basically the vector, because almost every external dependency is going to be a vector, although it doesn't have to be. Once you get into the camera and you've got focal values, then you get into number outputs, and then you can also do texture outputs if you create custom dependencies. But right now, the default connection of vector is what we want. What we need to do is multiply this vector by the internal unit, which will immediately fix our value. So I can type in a value of 0.1, which is what we're going to be using, although this can be changed at any point to whatever internal unit you're using. And now I'm going to publish this as scene internal unit. And now we have the scene internal unit showing up within our meta node. So what this has already done is taken our vector, and if we were to say have 10 meters, which would show up as a vector of 100, now that vector will show up as 10, which means we can type in a value a little bit later of 10, and that will automatically get converted into a value of 100, and then we'll be able to set our range controls, and you'll see how that's going to work. The first thing I want to set up now is we need to break up our vector into the individual axis outputs, x, y, and z. In order to do that, we need to create a math node. We're going to go to Vector Operations, and we're going to use the Decomposer 3. What this will do is take our vector, if we go ahead and connect this, and break it into 3 number outputs, the x, y, and z. And to make things a little easier to see, what I'm going to do is create a constant node, make this a connectable constant of a number, and now if we click on it and create our highlighted red box just by clicking in any area showing that view is ready to insert another node, we can click on that constant and it'll create another constant number and do that again. And these are going to represent our 3 axes. And this is just to keep everything nice and clean, and it'll make it easier to work with the node. I'm going to rename these to x, y, and z. And now these aren't going to be showing up in our output node. They're just a reference for us to work with while we're working on the meta node. And I'm going to select them and show the large text option just so we can see them a little larger in the interface. Now I'm also going to go ahead and zoom in so you can see this a little better on your screen. So now what we can do is take our constant and connect the value to the x, our y, select our z, and connect to the z output. So we now have our vector broken up, multiplied by our internal unit to correct any vector outputs when we want to enter in any manual number. And we have the x, y, and z broken up from our vector into individual numbers. So now what we need to do is add in our output nodes. Now we already have a double output which has been created. A double output is a number output. So we're going to need 3 number outputs. Right mouse click, add output node, double output, and do that again. So now we have our 3 outputs, and we can rename these x, y, and z. And these will show up in our meta node when we go to connect a number to the meta node output. It's going to give us an option to select the x, y, or z. So anything we define as an output will show up as an output when we're making a connection. So we can connect our x, our y, and our z. So now we have a very simple node set up. And we don't really have any options. We haven't really set up any of our controls, but overall, this will already work within a specific range. Since we haven't defined the overall range, it's going to be a little too sensitive. Just to show you how this is going to allow us to connect, I'm going to create a connectable constant number. And if we connect to our meta node, we can now see that x, y, and z, which are those double outputs we created within the node. And if you want, you can also take the time right now and save this out. And you can give it a version number if you want, something to let you know where you were at during the process. So if we select our node and hit save, I already have a file set up as range control. I'm going to save and overwrite it. And what I want to do is just delete the node, right mouse click, and now we can load it back in and we have the range control, and we can see that all set up. Go back and edit, and we have our node. So now what we need to do is define our range value for the x, y, and z. And basically, so we can type in, as I was showing in the explanation, a value of 10 so that we have a range of 10 meters to control the output of 0 to 1. And the goal of this node is to consistently create an output of 0 to 1, at least for right now. The node I showed before has a range output, which I had entered at 0 to 1, but when you start connecting it like we did before, showing with the largest feature of a fractal, we would need to adjust that control, but we still want that value to equal 0 to 1, and that's all done within the node. And we're going to do that after we set this up, because it is going to make the node a lot more complex. So in order to create that range, what we need is a blender node. We're going to set it to divide. And what we want to do is divide our output from the axis by our range. Since our internal unit that is being multiplied and multiplying to our vector is already decreasing our vector, then we can divide by our range value, and it's going to give us the exact output we're looking for. And what we need to divide it by is our constant number. And because I had the scene internal unit constant number selected, it created a duplicate with a published value. So we need to make sure we unpublish this as the scene internal unit, because we don't need to have more than one, and we don't want any conflicts. I'm going to set this value to 0, and we can just call this our x range right now. And I'm going to connect our x output to the divide, and we want to divide the output of the x vector by our x range. And we need to make sure we select that vector output that's been converted first, and then our x range. So now we can select this divide combiner, select the link between the y's, and add that, and do the same thing on the z. And I haven't published this yet because we are going to be making duplicates. And we can add more constants. So now we'll change this to our y range and our z range. And go to our other divisions and divide by these range numbers. So now what we can do is publish these within the node, and we are going to publish this as the x range. So we can delete this dash value that showed up and just do this for all 3 of the axes. I'm going to click OK, save the updated range control. So now we have our scene internal unit and the x and y and z range. Now there is no vector output at the moment. We are just creating the axis constraint for x, y, and z for controlling numbers. So what we also want is that ability to connect our origin. In order to do that, we need to add a few more modifications. And in the node I showed before, I didn't have these constant values showing up for the x, y, and z. So if you were to compare those two, you will not see these constants, the connectable constants on the top, but I am using them to organize this a little bit better. So what we want to create is our vector output. We're going to add an output node, vector3 output. And I'm going to call this vector. And that's going to give us the x, y, and z value so we can connect to things like the offset nodes. What we also want is the ability to control a little more of the range of the vector if we choose to. I also want to set this up so that it can be expanded in the future. So the connections I'm going to make right now might not be necessary, but will give us the ability to break it down a little more later if we wish to. So what we need to do is create another decomposer. Although we could connect to this same one, I do want this to be organized and easier to understand and use, so it's always a good idea to keep that in mind. So we'll go to Add a Math Node, Vector Operation, Decomposer 3. You could also select the decomposer, add another math node, and it will duplicate it. Connect our decomposer to this multiply output, and now we need to set up the same sort of division we had before. And what I'm talking about with the expandability is we do have the option to divide the entire vector with a constant vector. But if in the future we want to break down the vector a little more, then we're going to have to replace all of the nodes. So what I want to do is just create sort of the same connection, and then we can output it again as a vector by using the Composer 3 node. So we're going to add in our math node, vector operation, Composer 3, which is going to be connected to the vector. So we'll create some math in between to affect the x, y, and z individually, but the output will still remain a vector. So what we need to do is create our division combiners, and I'm going to add a constant node, connectable constant, and actually what we could do is just use a regular constant number, which all three of these will be divided the same. So right now we just can use one value to divide all three vectors, but in the future if we want to break this down a little more, it'll already be set up. So we're going to take our three connections from the composer, input 0 on the first one, input 1 on the second, and input 2 on the third. We're going to divide the x by that constant, and then the y by our constant, and then the z by our constant. We can also rename these x, y, and z. So now this is pretty much set up, and we're going to extract this constant number as the vector range. So now we have the vector range showing up, just like we had in our other node. So if we wanted to create, let's say 20 meters for our total vector range on all axes, we could just type that value in here. We could also break it down if we wanted to, like I was saying before, but this should be a really good starting point. And we're going to go ahead and save out this version, overwrite it. And now the finished node I had before has an offset, which allows us to manipulate the object ahead of time to position it in the scene without it affecting the control that we want. In order to do this, we need to set an offset after our internal unit conversion. So what I'm going to do is create a math node, set this to vector operation offset, and now what we need to do is connect both of our decomposers to this offset. I'm also going to change the default, which has a value of 1 set on the z already, change that to 0, and now we can connect the offset to the multiply back to the link in our chain, and we can extract and publish this as the offset range. So So we're already really close to the full node we had before. The only thing we're missing is our number control for our range. So right now this will work with any blender from a value to 0 to 1. And there's no modifications that need to be made if you're working with any sort of output that deals with 0 to 1, which is basically a large amount of the controls. And what I did was I went to create a blender node or a combiner. And because I had the meta node selected, it created a duplicate of our meta node because a meta node is basically a combiner node. So we can change this to the blender. And now we take a look at the ratio, 0 to 1. This will control on any X, Y, or Z change from any of our dependent objects, which we have not extracted yet. So let's go ahead and edit this really quick. And up for our external dependency, we are going to publish our dependency, which is going to be the object we decide to control with. And I'm going to call this controller. Click OK. And now we can see our controller is showing up. Now the order that we have these different settings showing up in are displayed in the order of their extraction. Same thing with the output nodes. The order we create those output nodes, being the double outputs and the vector outputs, are the order they're going to show up from the pull down. So if you want to reorganize this, which I ended up doing before with the other node, you need to unpublish all the values and then publish them in the order you want them to show up. Keeping in mind that not all operations will show up in the correct order. The offset will show up before any of these no matter what, in most cases. So we'll save this current version now that we have our dependency. So if we connect this to the X, we could choose our controller dependency. We could choose the main camera if we wanted, its position. You can also see that we have some values, focal, depth of field, that will be a number output. And in this case, it might not work. So this is really a vector control for position, size, and orientation, although it will work best with size and position. So we're just going to go ahead and test the node. Where we're at right now, we'll go into, and if you take a look, I closed out the ground graph we were working on and clicked OK, and when I went back to reopen it, you could see that everything we were working on was gone. So it's a really good idea to start that node as quickly as possible and start saving it, because the scene itself may not save it. So we're just going to create the same setup we had before, just creating a procedural terrain. And we're going to create our sphere, which is going to be our controller. We can edit the object. And I'm going to create up that same connection, just creating a noise node rather than a fractal. Set up our blender, where we have 0 being the fractal and 1 being the noise node. We can load in the meta node we just created, the range control. And we're going to connect it to the Z, control it with Z. And now we can choose our controller, which is the sphere's position. And let's go ahead and set that Z range to 10. And I'm not going to set up any offset range, although you can if you need to test it. I'm just going to scale down the output, scaling down our procedural terrain on the Z to make it so it's not quite so high. So now we can switch to the move gizmo. And if you don't have the gizmo showing up, you can go to display, gizmos, show gizmos, and I also have the helpers showing up, and allow moving outside gizmo. And right now we're using the position gizmo with the global coordinates. So the G for the global coordinates, and position, which is the top right little crosshair. So if we take a look at the position of the sphere right now, the Z is actually set to a -3. I'm going to change that to 0, which is going to give us that exact number of 1, or sorry, 0 for our output. And if we set up our range, change it to 10 meters, now we have the output of 1. So our range, if we set this to 5, now it's reversing, but if we set our sphere to a value of 5 and its position for the z, it's back to that output. So we've already created our range control that's going to work with any blender, or any output that is a value between 0 and 1. But the ultimate goal, and with what I had before, and the example I was showing you, we have a range output as well, so that we can select what is going to be controlled and the overall values. This is really easy to set up, although it does make the node look a lot more complex. It really is a pretty simple setup. So now we're going to be adding the output range control for our node. So what we can do is just select our ground plane, open the object graph. We're going to load in that range control node we've already created, but we need to create the output range control. By default, this of course only controls a value of 0 to 1. Although it will control beyond that, we won't be able to specify exactly the ranges. So what we want to do is set up that output so that if we want to control something other than a blender, or other than a node that only has an output of 0 to 1, we can do that. And this is also only going to work for the X, Y, and Z. And if we want, we can connect it to our vector in the same way we're controlling our outputs. In most cases, it will not be needed, although it is something we could move on to. We're not really going to worry about that, because the kind of control we need really is specific to the axis. And all we're really doing by adding the extra nodes, and we're just eliminating the need to create duplicates of the node. But it's really easy to create that sort of a duplicate, so I'm not really going to worry about that. So what we need to do is create our range control. So we need to be able to set a value that's basically going to be converted to a 0 to 1 output. Since this works perfectly with 0 to 1, all we need to do is modify it to change whatever output we specify and the numbers we input to be converted to 0 to 1, and that way it'll always work within our range. So this is a pretty easy setup. What we're going to do is create our blender, and this way we stick with our 0 to 1 output and it's compatible with the node. And we're going to create 3 different blenders, one for each axis, the X, Y, and Z. And now we need to create 6 constant nodes, or connectable constants, as a number. So now we have the first one created. We can highlight it and just create our duplicates. So we have 2 for each of our nodes. And basically we're going to have our low and high range for each output, and we're going to connect those to a universal constant number. So we're going to create a regular constant number. If you want this value to be something you can extract within the metanode or outside the metanode, then you can change this to a connectable constant, and then you'll be able to extract that from the side within the metanode. I'm going to stick just constant numbers right now. Although if we want to change it to an extractable, we can really easily do that. So we're going to create just our 2 regular constants. This is going to be our high range output, and this is going to be our low range output. So let's go ahead and zoom in. We're going to get a better look at our node structure. And what we're going to do is use all of our low values to connect to the same node. So all the left constants and extractable constants, we're going to extract the number connected to this low range, which is going to be our published value. Then we can take our high range and connect all of those to this value. Now we need to set up our blenders. Input 0 to the left and input 1 on the right, so our low and high. And now we can publish these values as the low range and as the high range. And now we need to connect them to our outputs. And how we're going to be doing this is connecting to the end of our blender the X, Y, and Z, and we're going to control the ratio of our blender with our current output. So now we have the X, Y, and Z connected to those division nodes we created, and we can move this in place, and we now have our low range and high range all connected to our outputs. Click OK, and now our node is complete. If we set our high range to 1, we're now working with the blender, and that's going to be compatible with any blender. If we're working with a different value, like I was saying before, we have a largest feature, which is 0.1 to 1000 if you're working with an internal unit of 0.1. If you're working with an internal unit of 1, it's going to go up to a value of 10,000. But since we're going to be using this with a blender for right now, low and high range at 0 and 1. We also have our vector range and all of other operations set up. Now, if we do want to modify the positions, as I was saying before, I'm going to go ahead and save this first. What you can do is go to all of your extractable values and extractable parameters, and if you just click on them to unpublish them, you can go back through and republish in the order you'd like them to show up. In some cases, things like offset range or our offset vector we have set up is pretty much always going to show up in front. Not necessarily, but it can vary. And if you want this to be a little more dynamic, you could go ahead and convert the X, Y, and Z that we have set up as constant numbers to connectable constants. And that way, within the node itself, we would have some parameter connections on the right and extractable values like we have for the offset range within the node. So you could have this controlled by multiple nodes if you're creating duplicates. So now we can start using this node to manipulate basically any sort of extractable output within the function editor. And by saying extractable output, I basically mean any sort of connection where you can extract and connect it to anything in the scene. And in this case, it would be whatever we choose as our controller object.